Most people look at a motor specification sheet and read only one number, kV. Professionals read more than that, because every number tells a different story. Today, we analyze the Emax RSIII 2306 brushless motor. Not casually, but logically. This motor comes in 3 kV options: 1800 kV, 2100 kV, and 2500 kV. We will go ahead 2500 kV motor. kV means RPM per volt. So, this motor gives 2500 RPM per volt on a 4's battery. The nominal voltage is 14.8 volts. Now multiply it with kV. That equals approximately 37,000 RPM. This is the theoretical no-load speed. No propeller. No resistance. Under load, RPM drops. Always remember that. kV tells speed potential. It does not tell torque. Now look at stator size. 23 mm by 6 mm. This tells us something critical. Stator volume. Larger stator volume means more magnetic interaction. More magnetic interaction means more torque. Torque determines how well the motor handles load. kV tells speed. Stator size suggests torque capability. Both must be considered together. Next, maximum continuous current, 43 amperes. Power equals voltage multiplied by current. So, for 4S battery, it equals approximately 640 watts. That is significant power. This means your ESC must safely handle more than 43 amps. Professionals always add margin. 50 amps or higher would be safer. Current affects heat. Heat affects efficiency. Efficiency affects flight time. Now we examine thrust. Maximum thrust is approximately 1.4 kilograms per motor. On a quadcopter, that means 4 motors. 1.4 kilograms times 4 equals 5.6 kilograms. Total thrust. Now apply the 2-to-1 rule. Divide 5.6 by 2. That equals 2.8 kilograms. That means the total drone weight should stay below 2.8 kilograms. Thrust is not fixed. It changes with propeller size. It changes with voltage. Always read the thrust test table, not just the headline number. Higher current increases heat. Higher heat reduces efficiency. Peak thrust is not peak efficiency. A well-designed build operates near optimal efficiency, not maximum stress. Motor selection is engineering, not guessing. So next time you open a motor specification sheet, do not panic. Look at kV. Check stator size. Calculate power. Verify current limits. Read thrust data carefully. That is how you select a motor like a pro.